Plans and elevations is a standalone subject which occasionally comes up, and it's fairly easy really, I think, to get good marks on. Remember, this is a plan. We are looking straight down on the object. It's like a map. You are looking down. If you remember that, it's a lot easier. Now, this doesn't need to all be in contact with the table. It could be a sphere, for example. But in this case, it is in contact with the table because we can see that from the elevation. This is going to be a circle. This is obviously a triangle from the side, and that is a cone. Again, this is a circle. This is an elevation. This width is the same as that. So this circle is, well, it's this circle on the top really, isn't it? And that is a cylinder, a circular prism. Here is a triangle. That's what we see when we look down on it. And from the side, we see this rectangle. So this rectangle is the same width. It's actually this side here. And this is a triangular prism. This is a more interesting prism. It's shape of a hexagon. I think I've given it the answer away now. This is the view from the side. This crease, if you like, is this corner here. That's a hexagonal prism. Get into the esoteric shapes and things. What have we got here? Well, this again, we're looking down on something. This is a fold, it looks like. Here's the view from the side. This is triangle. This is this shape here from the side, and that is a triangular pyramid, which gives the game away for this one. This is a square shape. Again, it's got folds, and this elevation is looking from the side at this side here, because this is pointing not quite up, but upwards. That's a square pyramid. Don't get many marks for that stuff, but you do get marks for this. Although you would do if you answered it correctly. Students are very bad at doing this, it would appear. Use the 1cm grid opposite to draw an accurate plan and side elevation of this cylinder. Right, we're going to have a little think before we get started. The key is this word, cylinder. A cylinder is always a circle. It's a circular prism. Although this looks like an oval, and many students when they did this drew an oval, that's actually a circle just viewed from the side. So my key technique for this is to try and imagine what this is in the real world. And for me, this is a small can of beans. And then you sort of get a feel for what it will look like in a plan and a side elevation. We know that it's circular, for example. Or we know we're going to use a compass, and we know the radius is going to be 3 because that's 6, so the radius is 3. So we draw our circle, plonk in the compass here with a radius of 3, draw a circle just going through these dots here. So that's a radius of 3. The side elevation, you do not see the top when you look from the side. The top and the bottom are parallel and they're invisible from the side. So you just see 4 centimeters high and 6 centimeters across, and so that's what you draw, this box shape. Notice the width is the same as the plan. It has to be, because that circle, if you like, is, if you're looking from the top, it's going to be a circle on the top of this cylinder. For checking, I just eyeball it. That's 6 across, well that's good, that's 4, and that's 6 across, yeah, that's fine. That should do. Thank you very much. 3 marks. Here's a harder one. 4 marks for this little gem. Again, it's 1cm grid paper, but you're making an accurate scale drawing because the cone radius is 20 and the cone height is 30 and it won't fit on the paper. So you're doing a scale drawing. 5:1 is the ratio. So you need to reduce these distances by a factor of 5. 30 becomes, well, let's have a think. It's a party hat for people with a big head. The height of it is going to be 6 centimeters, 30 divided by 5. We use a compass for the bottom because it's a circle, and the radius is 4 centimeters, which is 20 divided by 5. So on our plan, we get our compass and we draw a circle with a radius of 4. So it has a width of, diameter, I should say, of 8. The elevation starts off with this circle and goes up, and it goes up 6, and it will look triangular. So we need a triangle. The base of it is 8, same as the diameter of that, and it comes up 6. So for my checking, I just eyeball it. What have we got here? We've got something that's radius is 4, so that's 20. That's what we want. And this is 6 high, and that will give you, in the real world, 30 centimeters. So I'm happy with that. The key for me is to imagine what these shapes are in the real world. So this is a hard question, and I hope we've made it a bit easier, but it's still difficult. You still have to concentrate. Best of luck. Here we have the subscription page. If you enjoy this video, or even if you don't, why not subscribe and get more? If you're doing an exam in the short term, best of luck.